So my name is Kristina Eissenberger. I'm from Biobased University, and within Preserve, I'm the scientific and technical coordinator. For this workshop, we would like to please keep yourself muted during the presentations, and also please keep your camera off during the presentations, as this will help us maintaining the streaming quality. You can ask us questions anytime in the chat and then leave the comments there, or also after the presentations, you can raise your hand and ask them directly if you prefer that. Also, this workshop will be recorded, and the recording and presentations will be shared with you on our websites, which also means if you do not want to see your face on the recordings, also just keep your camera switched off. Okay. So I think there are still some people joining. But I will start. As I said, I'm Kristina Eissenberger. I'm from Biobased University. I'm a research group leader there. And ideally, my background is in microbiology. However, as I'm the scientific and technical coordinator in Preserve, I will now start this workshop and introduce you to the Preserve project so that you have an overall idea what it's about. But before that, I would like to introduce myself a little bit. I'm working at the Sustainable Packaging Institute in Sigmaringen, which is located in southern Germany between Stuttgart and the Lake of Constance. It's an old city, or older city with a historic center, and a not so historic building where we're located in the so-called Forschungsfabrik. Sustainable Packaging Institute, SPI for short, is involved in research and teaching in 6 thematic areas, and as you can already guess by the name, our research focus is on sustainable packaging concepts, because we are on the mission to competently and holistically support all players in the packaging industry along the entire value chain and the life science industry on the way towards a more sustainable circular bioeconomy. And as I said, we're working in 6 thematic areas, starting from biogenic raw materials, process technology and process design, functionalization of materials, smart packaging, which comprises active and intelligent packaging, preservation packaging, and also bioeconomy and sustainability. This includes concept development and packaging concept development, but also life cycle assessments, for instance, and consumer perception studies. We are involved in a number of projects and have already completed some projects, but now for today, I would like to introduce you to Preserve. So Preserve is a 4-year project that started in January 2021, which means that we will finalize the project in December of this year. We have 23 partners, including 7 research organizations and partners along the entire circular supply and value chain, with large end users and the largest bioplastic producer users association. And as you can see here, with the different sectors like raw materials, plastic packaging converting, end users, entry and upcyclers. And as you can see, for all of these sectors, we have at least 3 industrial partners. So I think we're really depicting the circular supply and value chain. But why is Preserve needed? So in 2021, 90 million tons of packaging were produced, which means that Europe is far from its sustainability goals, which includes the requirement of a recycling rate of 70% by 2030. In 2021, the recycling rates between the member states varied from 38 to 80%, with an average of 64%. Yes, 80% sounds great, 38 not so great. And also we have to keep in mind that this average of 64% is for all packaging materials, which also includes fiber-based packaging. And of course, fiber-based packaging has a very, very good recycling rate, whereas the recycling rate of plastic-based packaging is only around 40%. So we need high performance bio-based materials to be developed and produced. Their recycling approaches need to be better established and in motion to be able to be adopted rather quickly. And also for some applications, an extension of the biodegradability of certain biopolymers may be beneficial. So what are our objectives? So what we are doing, we start with new biopolymer synthesis. And what you can do with that is, of course, produce packaging. However, in Preserve, these biopolymers enter our bioplastic upgrading and upcycling toolbox, which includes protein barrier coatings and adhesives, PHA coatings, electron radiation treatment, and enzymation. And we use all these tools in different combinations to produce packaging, which will then also be validated. At the end of life, we have different options for the Preserve project. Depending on the material, we can go for biodegradation, which then, of course, results in the production of biomass, which can be used for new biopolymer synthesis. Or when we're talking about material recovery, also depending on the material, of course, we can go and aim for enzymatic recycling. So which means that the polymers are degraded or broken down into oligomers, which can then again be fed into new biopolymer synthesis. Or we go for delamination or self-reinforcement of bicomponent biopolymers. In both cases, we will receive recycled biopolymers, which can then again enter our upgrading and upcycling toolbox for the production of textiles composites, mainly in the field of personal care packaging and transport packaging. And of course, I would like also to show you some of our results. So for instance, when we're talking about a protein coating, we're talking mainly about whey protein coating within Preserve. Why? Because whey is a byproduct of cheese manufacturing, and the annual production is around 50 to 59 million tons per year, and currently around half of it is discarded. So it's a non-food competitive resource. It has the potential to be a bio-based alternative for EVOH, as it has really good oxygen barrier properties. And you can use this protein layer, can then allow for separation. As you can see here, these are theoretical, very artificial multi-layer of PLA, whey protein coating, and PET. And during delamination, this protein layer is dissolved and degraded, and then the two polymer substrate films can then be separated again and can be fed into their respective material cycles. Within Preserve, we upscaled it till the pilot plant level, and for PLA, we got a reduction of the oxygen transmission rate by factor of 26. For PET, factor of 3.5. And our colleagues from Fraunhofer IVV were even able to metallize this protein layer. And that led to a further reduction by a factor of more than 160 for PLA and a factor of 135 for PET. And in this case, so with the metallized protein layer, these structures even outcompete commercially available metallized PET and metallized PLA, as you can see here. And this is how it looked like. So very, very nice and shiny. Our partners then from Bioplastics investigated the delamination potential using enzymatic soaps. And as you can see, that investigated numerous different soaps and detergents, and in two cases for extrasim and sodium hydroxide, the delamination, so the degradation of the protein layer, was successful. So overall, what we do in Preserve is we have the potential of bio-based multi-layers to rethink food packaging. So what we can do, or what we're doing, is we go from flow packs, trays, pouches, and beverage bricks, add our bio-based design for separation and recycling for second high performance applications in personal care and transport packaging, such as injected jars, bottles, carrier boxes, and bags. And with this, I'm at the end of my presentation. I would like to thank you for your attention. And if you have any questions, I'm more than happy to answer them. Thank you. Okay, I will stop sharing my screen and maybe I'll be... Okay, so good, no questions. I think it's clear. You have hopefully a clear picture now of the project. So with this, I will then hand over to my colleague, Estela. Estela López-Hermoso will give us a presentation on navigating the regulatory maze. Estela has over a decade of experience in EU public affairs with a strong focus on bridging the gap between research, expertise, and policy. She excels in connecting stakeholders, technicians, and researchers with decision makers to advance key EU initiatives, and her expertise spans cohesion policy, Interreg, and Horizon programs. And as a EU project manager at European Bioplastics, Estela leads the development and implementation of EU-funded projects with a particular emphasis on policy, standardization, dissemination, communication, training, and stakeholder management. And she holds a degree in history and bachelor degree in history and master's degree in European disciplinary studies from the College of Europe. Estela, the floor is yours.
Thank you very much, Kristina. I'm going to share my screen just a second. I hope you can see it in full screen and you're not seeing my notes. Just a second, because I'm also managing here this Zoom. Okay. Okay. Just a second. So, thank you very much, Kristina. As you have already get a glimpse of what we do in Preserve, my task here today is actually to present you with the regulatory framework in which we operate, so to say.
I'm sorry, Estela, we can't see the screen yet.
You cannot? Okay.
No, we cannot see the screen.
Sorry about that. Just a second. So let me try again. Thank you for letting me know. Just a second. Again, we try it again. Okay, can you see it now?
Yes, not yes, perfect.
Yeah, perfect. Thank you, Robin. So, well, this you were seeing my face, I hope. So I was not, you were not staring at the black screen. So we are operating in a regulatory framework. Obviously, we are a research and innovation project. So we are, but we're working until pilot scale, as Kristina has said. But we need to take into account, obviously, the regulatory framework that is there and that it's to come for our solutions to actually come to the market. And the topic of my presentation is navigating the regulatory maze, the future of bio-based and recyclable packaging, and it's probably self-explanatory. Kristina already introduced me. I worked as EU project manager at European Bioplastics, which is the association representing the bioplastics industry in Europe. And we obviously work intensively monitoring and advocating for a regulatory framework for bioplastics. I have wonderful colleagues in Brussels working on experts on the science behind it and experts on public affairs that actually are the backbone of our association. And I support them and connect them with our EU projects. So today I'm going to be keeping it simple as the outline. So just going to be an introduction. Since I'm speaking about the future of bio-based and recyclable packaging, there's no way around the packaging and packaging waste regulation, the PPWR. Probably all of you know, have heard about this, even know in detail. Mind me if you know in detail. We can discuss it in the panel more concretely. But that is not the full picture. There are plenty of the deals, plans, initiatives, frameworks, regulations, directives, proposals, revisions, consultations, studies. There's everything in this world of bio-based products, and in this case, packaging and recyclable. So that's why there's a reason why we call it a maze, right? So, for example, you can see here, from the year 2008, I go that back far, because that's when we have the EU plastic strategy and the EU bioeconomy strategy up in place. And then in 2019, the EU Green Deal. And without that, we cannot understand. Hello? I thought someone was asking something. And without that, we cannot understand that those are the frameworks in which we operate, right? But you can see there's over 10 initiatives, right? Concerning bio-based plastics, recyclable packaging, food contact materials. And all this highlights the European Union's commitment, right, to address environmental concerns, climate concerns, safety and consumers' rights, the bioeconomy, circular economy, competitiveness. So there is a reason for all this, but there is quite a turnover of initiatives there, right? So this might bring regulatory uncertainties and inconsistencies and disconnected frameworks, right? And sometimes we have observed discrepancies between the high-level political support, strategies and initiatives, etc. This list is again in more detail of a list of proposals, directives, regulations, etc., that might somehow that we need to take into account, basically, for the Preserve project. So the researchers, the companies, the producers, the institutes that work at in this project. So, having said that, I go back to the PPWR. Why? And why am I focusing today on this? Well, as you know, probably the European Commission proposed this new regulation some time ago already, in November 2022. And, well, it's about packaging and packaging waste. And only by April 2024, there was an agreement. But there's currently, the text is going through this corrigendum phase, in which it's being checked for languages and legal aspects, but probably will be finalized by the end of the year. But that's not the whole story. Then, once this final text is there there's many secondary legislation that actually needs to be developed, because that's when the real work starts. The PPWR is, so to say, a regulatory framework that is directly applicable in member states, but that needs secondary legislation to actually make it work in many aspects. So I will refer to, and you will see in my presentation, some of them that I highlight. And this is the key. This is the key. No, the devil is in the detail. This secondary legislation, it's actually pretty important. The Director General for Environment in the other European Commission, together with the Joint Research Service, the ECHA, with other inter-service consultation with other DGs, they're all working and consulting also stakeholders to make this work. So this is going to be this is happening already. This work has started already, obviously, but this is going to continue in the next years. For example, criteria for recyclability, recycled content, etc. So the key elements, just briefly, I will not enter into all of them, but for example, apart from aiming at preventing unnecessary packaging and packaging waste, the provisions on sustainability criteria, for example, like the ban on forever chemicals and on compostable packaging, the key elements of the PPWR in the realm of activities of the Preserve project are more into the packaging design for recyclability, So recyclability standards, recyclable content targets, recyclable at scale, labeling, and also, of course, the provisions referring specifically to innovative packaging. So that's where I'm going to focus on. So recyclable packaging, PPWR, what does it say? All packaging placed on the market should be recyclable. Okay, great. What is considered recyclable? I'm not going to delve too much into detail, but if it's designed for material recycle, when it becomes waste, it can be collected separately, sorted into specific waste streams without affecting the recyclability of other waste streams, and recycled at scale. So this will have to come with a delegated acts and implementing acts. So here's where it comes, the secondary legislation, the key, the devil in the detail, which is not a devil, because this is also an opportunity to actually establish a solid base in which bio-based packaging can operate, right? So this is a challenge and an opportunity, both. So the manufacturer also shall assess packaging recyclability on the basis of the delegated act and implementing act. So this secondary legislation will be very crucial. By January 1st, 2028, the Commission shall, after taking into consideration standards developed by ITSEN, we'll speak more about this later, so by the European standardization body, adopt delegated acts to establish design for recycling criteria and the recycling performance grades, these A, B, and C that are now going to be the standard. By 1st January 2030, or 24 months after entering into force of the Delegate Act, packaging shall not be placed in the market if it's not A, B, or C, and by 1st of January 2038, if it's not A or B. Here is the table. You will have the presentation, and you can find the same table in the text voted at the European Parliament. Once it's consolidated and the corrigendum is finished, you will have access to the consolidated version. But this is the table, and these are the criteria, the grades and the percentages that need to be achieved. Okay, that is clear in principle, but then we need to take a look at the design for recycling criteria. Okay, so from 2030, recyclability performance is based on design for recycling criteria, okay, to ensure the circularity of the use of the resulting secondary raw materials or sufficient quality to substitute the primary raw materials. So this is, as you might have seen already, and by the presentation that Kristina made, we are working on all of this. We are already visionaries in a way, right? We are innovating in this realm. So we're working towards this already. From 2035, recycle at scale. So based on an assessment on the quantity of the material effectively recycled from each of the packaging categories, according to a methodology established in future implementing acts. So methodologies, criteria, all this are going to be sorted out in this secondary legislation. Therefore, the importance of it, we need to get it right, everyone. The European Commission is consulting stakeholders, umbrella organizations, to really discuss everything to the detail. According to Recyclable at scale measures at the PPWR, again, by 1st of January 2030, there should be implementing acts, establishing the methodology for this, and the chain of custody. By 2035, on the basis of the development of the sorting and recycling technologies, the Commission must review the minimum threshold for packaging to be considered recycled at scale and present perhaps a legislative proposal. So as you can see, this is going to be work for this work that has already started is going to take quite some time and poses some uncertainties, and some eyebrows might be raised about how is this all going to fit and how is the Commission going to avoid inconsistencies that already exist, and with all this myriad of secondary legislation that will come, then how is this going to be also avoided? In case of the innovative packaging, that's where we enter. From the 1st of January 2030, innovative packaging must be placed on the market for a maximum period of 5 years. Okay. Then the producer, the economic actor, should inform the authorities about this, and then check about if this is innovative packaging, and if it's not considered innovative packaging, then has to comply with the other rules that we have seen so far. So this is actually also quite important to categorize this innovative packaging, and to actually argue why is this innovative packaging and why not. And member states shall continuously, in the meantime, improve collection and sorting infrastructures for innovative packaging, because without that, we know that this is a crucial aspect. By 1st of January 2035, also the Commission shall review the exception and perhaps assess the situation, and perhaps propose a legislative proposal on this. So the PPWR also establishes many instances in which things are going to be reviewed and reassess to adapt to the state of play of the innovation in packaging and in recycling, which is good. Then there is also the aspect of the minimum recycled content, which also, as you can see here, I included all this text, so you have that in the presentation. But by January 2030, or 3 years after the date of entry into force of the implementing act against secondary legislation, it's already read everywhere in the presentation, then there are certain percentages of recycled content recovered from post-consumer plastic waste. This is important also for what we're doing in Preserve, and per packaging type and format. So we have here the categories A, B, C, D, and the percentages first in 2030, but then they change in 2040, become more stringent. And again, by end of December 2026, the Commission shall adopt implementing act establishing the methodology for this calculation and verification of the percentage of recycled content. Of course, this methodology is the key, and this secondary legislation, again, is the key to establish all these methodologies and criteria that then it's the basis of all the targets that need to be complied with. Again, by also at the end of 2026, the Commission shall adopt delegated acts to supplement all this with sustainability criteria for plastic recycling technologies. So all very, as you can see, it's very, very complex. But beyond the packaging and packaging waste regulation and its secondary legislation, as crucial as it will be for the sector of bio-based and recyclable packaging, there are other regulatory files that carry significant weight in this and that are complementary. Many, actually, as you have seen at the beginning, right, on this timeline and on this list. One of them is the Eco-Design for Sustainable Product Regulation, which entered into force in 2024. Another one is the so-called Green Claims Directive that is right now being worked on. Another one is the revision of the contact material, the food contact materials that was planned for 2023, but it was considerably delayed. There is the microplastics initiative with all the REACH restriction proposal on intentionally added microplastic. There is really a myriad of things. And it's ever evolving, actually. And even the standardization efforts that accompany all this and the secondary legislation, right? So, for example, CEN is working on a standard on design for recycling, on a standard on plastic packaging recycling. Also, the PPWR asks in the PPWR, there is a reference for a future packaging minimization standard, compostability standard. In the meantime, the Joint Research Center is carrying out that research focused on harmonized waste sorting labels. All this is affecting what we're doing at the project. So it's very difficult to monitor. There's also, for example, an implementing act being worked on chemical recycling linked to the single-use plastic directive. So there is really a lot. And the simplified timeline here shows already some of the files that are ongoing, what I just mentioned, but we know that it's not the full picture. We have the secondary legislation. We have also the review of the Circular Economy Action Plan, of the bioeconomy strategy. We have also the standards that I mentioned, the Chemical Recycling Implementing Act, and many more, because the European Commission is going to start, the new European Commission is going to start is going to be officially the College of Commissioners probably presented in December after the hearings at the European Parliament. And then this new commission and with this new political drive will obviously work as well on the main strategy. So many more will probably come. We have preserved work together with other sister projects on a white paper on upcycling food and drinks packaging as part of our effort to present to policymakers what is that we innovation and research projects on the field of bio-based packaging are doing. And we identified as a key challenge, as it cannot be surprising, the regulatory uncertainties and with the compliance and safety standards and production and innovation. And we put forward some recommendations. So I invite you all to check the white paper on Synodo. These are some of our recommendations in this field, in this realm. And there is obviously what we have identified as a great need to harmonize policy frameworks and to avoid inconsistencies and to ensure the participation of relevant experts. And in all these discussions for all these files that are ongoing and they will come, it's pretty crucial to detangle this maze and to make it easier actually to achieve ultimately the EU goals on sustainability. So I know that it was a lot, but we have time later for questions in the panel or now if you want, and you will have the presentation with you. Thanks.
Thank you, Estela. Wow, that was a lot of information. But thank you very much for bringing this to us. And we actually do have some questions. Okay, so one is which other biodegradable plastics other than PLA are covered in the project. I will take that question real quick. So we cover whey protein coating and sort of films. They are biodegradable, and we also cover certain grades of PHA and PLA, yeah. And then there is one question. Could you please mention the legislation dealing with harmonized sorting labels? Estela.
Yes. Well, there is the legislations on harmonized sorting labels. There is right now the Joint Research Service of the European Union is right now carrying out this research on actually harmonizing sorting labels in the framework of this revision of the packaging waste regulation. So this will come in the future, and it's right now undergoing. So this is something that it's pretty needed, obviously, but it's undergoing. Right now, I don't know the timeline of when this is going to happen. As far as I know, this is really right now on a consultation of stakeholders phase. So this will probably take some time actually to come out as a proposal, and I don't know in which kind of form of kind of act.
Okay, yeah, act is also a good word, because there's also another question. Could you there was a bit of uncertainty. What is the difference between delegated and implementing act? If you could just answer that question maybe with one. You're muted, Estela.
Sorry about that. Yeah, these both are secondary types of acts, and I don't want to say anything false right now. So let me confirm my knowledge, and I'll answer to you in the chat. Okay.
Okay, great. Thank you, Estela. Okay, so up next we have Robert Bishop. He will give us a presentation on processing and reprocessing of plastics and bioplastics. Rob has studied industrial engineering chemistry at University of Ghent. He has been working for 4 years at Santexpel, where he is involved in project focused on recycling, processing, and characterization of polymers and biopolymers. And his work in the Preserve project is focused on the upcycling of bio-based materials. So, Robert, the floor is yours.
All right, thank you very much, Kristina. So I will be talking about both the reprocessing and mainly also the processing of different biopolymers. This will not be only the Preserve project, but I will also involve some different projects that we have here at Santexpel that we are involved in, because I really want to show the possibilities that we can have with biopolymers. Not only the importance of just changing from conventional polymers to the biopolymers, but also some specific really interesting ideas that we have by using the biopolymers itself. But first of all, I will just give a short introduction on Santexpel itself. So we are a research and technical center located in Belgium, and we are focused on both the textiles and plastics. So we first started with textiles. So we have a very big lab that we use for testing all the textiles, both physical, chemical, fire lab, and also microbiological lab. But also we have a plastic lab. So it's located in Kortrijk, where we have mainly the extrusion pilot platforms for making both textile, but also the plastic parts. So I will give a short outline of this presentation. So like I said, it will not only be preserved, but I wanted to show some interesting results from different projects. So here you can see all the projects that we will speak about, that I will speak about. So bio on top, bio uptake, suspense, and preserve, and then also a little bit of title about specifically what in the projects are we involved in and what type of interesting results do I want to show you. So I will start up with bio on top, which is really about the tailoring of biodegradation, which is a super interesting project because we are specifically, you can see also in the top right, I want to mention, it's a European BBI project, Bio on Top. And here we are involved in making the tea bag demonstrator. So we are making a tea bag, which also has some specific, interesting difficulties in making this tea bag demonstrator, as also with hot water with 100 degrees, you need to be able to make this and still be strong at that temperature, but also the filaments itself. So this is a textile demonstrator where we make filaments that are very, very thin. So 30 dtex, which means it is 3 grams, 1000 meter of the filament is weighing 3 grams. And it has a strength, very high strength of over 35 centinewton per tex, which is a PLA-based filament. But I also want to mention that I cannot, because of its confidential information, give really the full material characteristics of which type of polymers, how much, etc. it is made of. But just generally, I can mention it is a PLA-based one that is home composed. So we made both a copolymer, but also blending with other polymers. So PLA-based, but also blending with others. And I want to check here with you. So here you can see the biodegradation of home composting. So these are home composting conditions. You can see the blue line being the cellulose as really a reference material, and also the green line, which is the reference of the PLA itself, because PLA is not compostable at the home compost conditions. And here I want to mention the PLA blends. You can see all the different other colors that we have made different PLA blends What is important to mention is the crystallinity, because really the biodegradation level and the fastness of the biodegradation level is really also comparable with the crystallinity. The more crystallinity it has, the less fast it will biodegrade. And when you look at just the pellet version of the material, so not when we stretch it, so it has very low crystallinity, it will really have a much faster biodegradation. But when we go to the fiber, which has a 40 or 35% of crystallinity, depending on the characteristics, the settings that we use, we can have a less fast compostability, biodegradability, and this we can actually tailor by using different types of polymers, different blends, different ratios, etc. And you can see here this in the graph that we already have made. For example, this red one is a totally different composition than the others, the black, purple, and brown graph. And also to mention, just shortly, the maximum duration for home compostable conditions is 1 year. So that's why really when you see this, the red graph in comparison to the other ones, you can see really the time difference between all these materials. And also what I want to show is the strength of the material, because when we work with PLA blends, PLA is a very good, very strong material, but when we blend it with different other polymers, then it gets actually, they have less strength. So this is also influencing in the total strength of this material. On the left, you can see the reference of the PLA. You can see a tenacity of around 50 centinewton per text with an elongation of around 20%. When we blend this together with polymer 1. As I said, confidential information, I cannot really give the type of polymer itself, but you can see here. So the difference here is actually the percentage of polymer that we blend into the PLA. The left one is with the least amount of polymer 1. The right one is with the most amount of polymer. And then you can see when adding only a little bit of that polymer, we don't really see statistically there is no difference in the strength of this material. But when we go more and more into this, creating more and more the polymer 1 into this blend, then you can see that also the strength of this material is lower and lower. But still above 30 centinewton per text, around 35 we wanted to reach with this TPEC. So this is pretty good. Polymer 2 is another polymer, a different polymer. And here it is not the weight percentage that we really looked at, but only the grade. So we have different types of grades where the polymer itself is different, but the type of polymer is the same. And then we can see with the different grades that we also see different strengths and also different compostability levels of this. So this is really the idea of this project, Bio on Top, that we wanted to reach, is tailoring this biodegradation by creating with different polymers, but also different weight ratios. We try to check how fast can it be and what is necessary for this. So not only for the TPEC demonstrate this is interesting, but very overall, this is a very interesting way of really using the biodegradability of PLA and also other polymers and tailoring it to your advantage for this specific demonstrator or specific need that is necessary into other projects. So this was Bio on Top. When I go further, I will talk about bio uptake, and also suspense will be a little bit about this, where we will create bio-based composites. Now, what is a composite? There are actually two ways of creating a composite, and also you have two different materials. So it's important you have a low melting temperature material, and you have a high melting temperature material. And when you look at the first one, so this is commingling, we will make them separate. We will make a yarn from a low melting temperature, and a yarn of a high melting temperature. Then we will combine them, we bind them together to make the composite, and then we melt it. And we melt it at the temperature that is between the melting temperature of the low one and the melting temperature of the high one. So actually you keep the strength of the high yarn, the high melting temperature yarn, and you melt the low melting one into the matrix of this composite. And then you get a very high strength composite. The other option is by using bicomponents. So then you will actually make the material together. You will produce the low and the high melting yarns together, where you can see that you can create actually in the center, you have the high melting one, so the one with the best strength, the highest strength one. And on the outside, you have the low melting one. So again, when you heat it up to a temperature that is between the one of those two polymers, then you will be creating the matrix, melting the low melting one into this, and again creating the composite. The main difference between the two is also that by the first one, the commingling, we use multifilaments, and by the other one, we use monofilaments. So also with the thickness of the yarns, it's a bigger difference in, but we can do both at Centex. Just to give an idea of how it's used here in BioUptake, so it is actually used we are making the yarns. It is not only PLA, but also PCL. So PCL is also a low melting one we can use to create a matrix. And then we will send it to the other companies who then create these composites, which will then be thermoformed into a demonstrator. And the demonstrator here is these feed insoles you can see here. And then some technical information in how we can create this. I wanted to show because the bicomponent is sometimes a little bit difficult to understand as well how this is created. You can see here on the picture on the right, we have put a yellow master batch in the center of this material. So you can see that on the outside of the material, sorry. So you can see it's yellow on the outside of the fiber, and in the middle one, it is just no color because we did not add color in this way. And then you can see really that we have on the outside the low melting PLA one. And also with PCL, we have tried different combinations, different types of grades, but also different ratios to see which one has the best strength and also performance in making the composites. So that was BioUptake, and then I go over to Suspense, where we are mainly looking into bio-based lignin from the bio-based material as bio-based material. Just a little bit out of the project itself, it's a Horizon Europe project, Suspense, that is focused on, again, making lightweight and sustainable composite parts by using these bio-based materials. Also, recycling is in the project, but right now, as the project is ongoing, recycling has not been looked into yet, just making of or producing these bio-based lignin components. So this is really what we are trying to make. So on top, you can see the standard, what is used now conventionally by using fossil-based acrylonitrile, by using wet spinning as a precursor fiber to then make really the stabilization and carbonization into the carbon fibers. So really the carbon fibers, and from that the composite materials from carbon fibers is what is used right now, but we want to do it from a bio-based perspective. So by using bio-based lignin, which is widely available as well, and then making this precursor fiber from this bio-based lignin. Also, like I said, this is together with bio-based polyamide. So by using this, because lignin producing at 100% lignin is super, super difficult. So you are mixing it with another polymer, and in this case, a biopolymer, bio-based polyamide. And by using melt spinning, you can create this precursor fiber, but then again, in the project, with some carbonization, is then turned into the carbon fiber. Here's some technical information about this, like how are we doing it, how much percentage can we go to, and really we see that we can go up to 40% of lignin already into the melt spinning one. By compounding, we already can go to 50% lignin, but then when we try to do that, we have to dilute this into the melt spinning line that we have at Centex because it is too difficult still to do 50% of lignin. Another type that is important to mention is, like I said, we use the bio-based polyamides as a mixer with the lignin, but it is also important to note that there is different compatibilities with the bio-based polyamides. Especially you have polyamide 6, you have polyamide 11, 510, etc., and we have tried to use all of these different ones, and then the most promising ones we took out was the polyamide 510 and also the 513. Right now, we have already done the melt spinning. We have the yarns, the precursor ones available, and now these are turned into then the carbonization yarns, but this is still ongoing. So like I said, it's a project ongoing and still in the early stages, but also the idea really here is to then take this to the recycling as well. And then the last project I'm talking about is, of course, the preserve project, the one that already Kristina and Estela has been talking about preserve, where we will talk about two different ones. We already had the questions, which type of materials are you using? Well, we are talking about two of them here. First of all, with PLA, but not the standard PLA. I already talked about this in the other projects, in Bio on Top and Bio Uptake. No, it will be more about the recycling of PLA. So recycled PLA materials that we make in the upcycling part of the preserve project. And then on the other hand, I will also talk about PHA. So firstly, just a standard overview. What are we making in preserve? How does PLA fit into this? Well, first of all, we have the food packaging. So what we would try to do is try to make bio-based and also recycling food packaging. So we have different companies into this project, like Ferrero, like Denim X, like Danone, and their food packaging we try to make fully bio-based. So very difficult, fully bio-based, and part of that will be PLA. Now, this PLA, what we also try to do is make this recyclable food packaging. So the materials that are used in this food packaging, like PLA, we will recycle into other demonstrators. And therefore, we have chosen a couple of them. Mainly for PLA, this will be the carrier box and also a textile bag. So their PLA we will use from these food packaging demonstrators and recycling them into other type of demonstrators. So first of all, is it possible to recycle the PLA coming from these food demonstrators? What is really still the strength of this PLA? Is there a big difference or not? And the biggest difference, because we will try to make these textile, we will make the textile bag and also the carrier box, we will need to make non-wovens. Non-wovens will be made from multifilaments. The food demonstrators are mainly used in film extrusion. So taking these PLA from film extrusion into filament extrusion is already a big difficulty because the low melt strength of this PLA. So we will need to upgrade this low melt strength of the PLA by using some additives. On the other hand, we also have tried to look at different types of PLA, different types of recycled PLA, and comparing them to conventional PLA. This is still somewhat ongoing as well, but we have some RPLA from Südpack that has really good already mechanical properties compared to some conventional ones like the 2003 DPLA, which we also had some recycled ones, as you can see on the left, but they are far inferior compared to the virgin one. So we are working with this RPLA from Südpack, which is a film grade PLA. Now, using these additives, we will increase the melt strength. These additives are not chain extenders because the viscosity of just the RPLA itself was good. But these are really additives only specifically tailored to increase the melt strength of this PLA, because going from a film grade PLA to a multi-filament grade PLA where you really stretch the PLA a lot, this is the main problem. But we have succeeded in the project to make 50 kilograms of the RPLA multifilaments, which then we made into some non-wovens. You can see here 3 pictures on the bottom where we made 3 different types of non-woven. On the left side, we have made this together with denim fibers, so recycled denim fibers from the company Denim X, which is a thick non-woven which will be made into the carrier box. And then the 2 on the right are actually 2 different ones with 2 different thicknesses that are just pure RPLA non-wovens. Also to mention, the additives that we have added are checked and are good for also biodegradation. So they have no negative impact. They even have a small positive impact on the biodegradation of the PLA itself. And then here, just a slide also specifically for the demonstrators itself. So what we will make is, like I said, the 2 textile demonstrators, a carrier box and textile bag. And the carrier box will be made from the Denim X material together with the PLA fibers into a hybrid non-woven. Additionally, we have also in the Preserve project, Estela has also created a finish to reduce the microplastic release. Because especially with the non-wovens, you can see that there are fibers that can become out of this non-woven. So with this microplastic release finish, we can actually reduce this these microplastics by up to 88%. Also, this is still at the end of the project. Still, we will make this and check this also together with the biodegradation to have a really good full overview of this. Then I will go over to lastly to the PHA that we have used. So in PHA, how is this used into preserve? Where there are actually two main questions that we are using into using this PHA into multi-layer packaging. So first of all, can we make a polyethylene paper packaging easier to recycle? And then also secondly, can we switch to bio-based barrier coatings? So using fully bio-based materials, can you actually reach these high requirements for barrier coatings that we need in the demonstrators we have for cups, bricks, trays, etc. So PHA can be a solution to this. PHA is used as a barrier coating using the plastisol method. Now, what is really a plastisol? That you can actually make this by using a polymer powder and a plasticizer. Then you create a very high viscosity material that is frequently used, can be used in coatings and also in screen printing. We have Centexbel has a patent on this that is also using a solvent-free and water-free materials and usage of this. And it requires heat to cure this. And the main reason why using this plastisol, why this is important to also use PHA, is not only to make it fully bio-based, but also more than 95% of the market right now is PVC. So both making not only bio-based, but also a biodegradable plastisol that is based on PHA is possible. Next, I want to show you the barrier properties. So I told you can we reach? This is a very big question. A fully bio-based material that has some high barrier properties. And here you can see with the water vapor transmission rate of the PHA coated paperboard. So this is coated twice with each layer being 30 microns, very thin. You can see with different conditions. So from 38 degrees with humidity of relative humidity of 90%, or 23 degrees, or even 6 degrees, you can see that we have different, very low, very good barrier properties actually that we can reach with the PHA. You can see as well here, which is the type of norm that is used by measuring these barrier properties. Other applications that this PHA can be used as well that we have tried is in a bacterial leather. So trying to make a leather by using also the PHA. You can see here on the right a microscopic graph of the different layers that we have used. So we have a cotton carrier as a base, which then is coated with a bulk layer of PHA, and also on top a varnish of a biodegradable polyethylene. So thank you very much for your attention. As I tried in this presentation, is to show you that not only is it really important to go from the conventional plastics to bio-based plastics, and also, of course, it's important, bio-based or not, to really be able to recycle this. And this is what we have tried to do and preserve, to really not only go from bio-based, fully bio-based, but also to be able to recycle this further into other demonstrators. But also what I wanted to show you here with these different projects is really specifically for bio-based polymers, that it's not only important to go from conventional ones to bio-based ones, but also that these bio-based polymers have some specifically very good characteristics, like this biodegradation, that we can use specifically into some demonstrators that can be super, super helpful to make them even better. So thank you very much. If there are any questions, feel free to ask them.
Thank you, Robert, for providing the insights. It was very, very interesting. And I actually do have a question. Because you showed all these composites that you are working on in this different projects, and recycling composites is, well, let's say challenging. For these specific composites that you are working on, or from your experience, do you think it is possible for certain composites to be recycled? And if so, what would be the requirements? Or
Yes. So first of all, I think these composites are definitely be able to recycle them. In the project, we are not yet looking into this. Again, it's an ongoing project, but because this is really a PLA composite made of two types of PLA, a low melting one and a high melting one, this will increase the possibility to be able to recycle. So especially because it is PLA, not only bio-based, biodegradable, but also the same material, which is definitely more helpful to be able to recycle these composites.
And for multi-material composites?
Yes, this is far more difficult to recycle them, especially it depends, of course, on the type of polymers. If there is a very high melting difference or not. So that is for the multi-material composites, it is definitely more difficult to recycle them. There it would be more looking into the biodegradability of them.
Okay, thank you very much. If someone else still has questions and is maybe to ask, to try to ask them now, please, you can also write them in the chat. Thank you again, Robin. And now we come to our final speaker, which is Carla, who will give us some insights on circularity assessment. Carla studied environmental sciences at the University of Valencia. She has been working at ITN for 5 years on life cycle analysis as well as circularity and eco-efficiency in European projects on consultancy. In Preserve, her tasks are focused on carrying out the circularity analysis of the demonstrators and comparing the results obtained with our benchmark references. Carla, the floor is yours.
Thank you, Kristina, for the introduction. I will share my screen. Okay. Oops, sorry. Okay. So hello, everyone. I will speak, as Kristina commented, about the circularity assessment and an example to an approach to a case study that is being done in Preserve. So first, I would like to introduce circularity for those of you who are not familiar with it. So the aim of Preserve is, in this task, is to determine how circular the value chain of the materials and products developed within Preserve are. So first of all, we should answer this question. What means circularity? So for now, well, the circular economy is a model of production and consumption which involves sharing, leasing, reusing, repairing, refurbishing and recycling existing materials and products as long as possible. So in this way, circular economy says that the life cycle of the product should be extended. So in practice, it implies reducing waste to a minimum. So when a product reaches the end of its life, its materials should be kept within the economy wherever possible. So this can be productively used again and again. So we are creating further value. So this means a departure from the traditional linear economic model, which is based on a take, make, consume, throwaway pattern. And this model relies on large quantities of cheap, easily accessible materials and energy. So for assessing the circularity assessment, we should mention the Ellen MacArthur Foundation and the guides that they already have on how to assess circularity. So according to this foundation, the current economy can be described as linear. So virgin materials are taken from nature, then are used to make products, and after they are used, are disposed. So we have the take, make, dispose model. So the main problem here with this linear model is that it creates high levels of waste and dependence between economic development and inputs of new virgin materials. So due to the results that are finite, this model cannot work in the long run. So the opposite concept is the circular model, where it's an economic and industrial model that is restorative and regenerative by design. So we move from take, make, dispose from a linear economy to make, use, and recycle in a circular economy. So the circular model is based on 3 principles. So the first one is design out waste and pollution. So it focuses on eliminating waste and pollution at the design stage. So by rethinking product design, businesses can reduce environmental impact. So this involves creating products that do not generate waste, utilizing non-toxic materials, and designing for longevity and recyclability. So then we should keep products and materials in use. So this principle emphasizes the importance of maintaining the value of products and materials by designing for reuse, repair, remanufacturing, and recycling. And the last principle is to regenerate natural systems. So the goal here is to enhance and restore natural ecosystems. So by returning valuable nutrients to the soil and avoiding the use of non-renewable resources. So this principle supports the regeneration of natural systems, contributing to improve environmental. So in Preserve, we selected some indicators from the analysis of the circularity. So the first one is the material circularity indicator. So the presentation of today is focused on this concrete indicator. But we also, as there is another task related to life cycle assessment, we also selected some of the indicators of this task. Okay, so we also select climate change and water use depletion, or water scarcity, and cost. Okay, so these will be all the indicators that we selected for Preserve. So the idea here is how we assess the circularity assessment. No, really, what we do is to first assess the circularity of the benchmark. So the products or the packages that are currently on the market, and then we compare the results that we obtain for the demonstrators that have been developed in Preserve. So as commented before, I'm going to focus in this presentation on the material circularity indicator, the MCI. So it measures the extent to which linear flow has been minimized and restorative flow has been maximized for its component materials. So it measures how long and intensively it's used compared to a similar industry average product. So here we have to take into account that it's essentially constructed from 3 product characteristics. So the first one is the mass of virgin raw material, which is used in manufacture. Then the mass of unrecoverable waste that is attributed to the product. So the end of life of the product, if this product is recyclable, compostable, or it cannot be. And the utility factor that accounts for the length, so the length and the intensity of the product's use. So here you have the formula. Okay, so it's this formula should have a result between 0, which is linear, and 1, which is fully circular. So any product that is manufactured using only virgin feedstock and that ends up in landfill, so it's not recyclable and not sent to energy recovery at its end of life, it can be considered a fully linear product. So here the material circularity indicator will have a result of 0. On the other hand, any product that contains no virgin feedstock, so could be from sustained production, for instance, or it's from recycled feedstock, it's completely collected for recycling or component reuse at its end of life, and the recycling efficiency is 100%, can be considered fully circular. So the product will have a result of 1. In practice, products will sit somewhere between these 2 extremes, and we are measuring the circularity range in the level to 0 to 1, from 0 to 1. So here you have the formula as I explained before, but this formula is fit with a lot of other formulas. So you have here the linear flow index, the virgin feedstock, the unrecoverable waste. So for these formulas that we have here, we need to know if the feedstock is derived from recycled sources or from reused sources, or if it comes from biological materials that originate in sustained production, and also the mass of the finished product. Okay. Apart from that, and when we focus on the end of the life, we need to know the mass of the product that is being collected for recycling, the mass of the product going to component reuse, or the mass of the product that can be used for energy recovery or being composted. Okay, also, as commented before, we have to include the efficiency of the recycling processes at the end of the life, or the end of its use phase. Okay, and that's all. Okay, these are the formulas that are needed for this in order to calculate the linear flow index that is needed for the material circularity indicator. Apart from that, we also need the utility factors. So it measures, it compares with the product we are analyzing with the lifetime industry average and the real lifetime of the product. and also the capacity. Okay, if the capacity of the product it's not the same at the average industry, then we have to take this into account. Okay, so here I will focus on two examples. Okay, the first example is this beverage package, where we have the cardboard component of 85% more or less, and then the PE, okay, which is mostly 15%. So here also regarding the end of life, this package can be recycled in almost 82.50%. And then we have a small amount that goes to energy recovery, which is more 9%, and another small amount that goes to landfill, which is 8.60%. So in order to calculate the MCI, we need the formulas I have commented before, but here I have included the result from the virgin feedstock. So here, what is the virgin feedstock? It's the polyethylene, okay, because the cardboard is supposed to be originated from sustained production. Okay, and it's 3.49 grams. So the weight of the beverage is almost 23 grams. And then we have the linear flow index, which is fed with this virgin feedstock and all other formulas that I commented before. So in this case, it's 0.22. So in practice, what we will obtain would be the MCA circularity indicator of 0.78, which is really good because it's really near 1. It's really it could be mostly set on the part of the circular product, and also here I forgot to comment that for the utility factor we consider that the same lifetime industry average, and the capacity also is the same. Okay, so from an industry average. So here then the result we included that is the utility factor was 1. Okay, so here would be the result for this first case study. If we focus on the second case study, here the things are a little different. So here mostly the material of this flow pack is almost 86% or 87% that's made of polyethylene, and also 13% of an adhesive. So the end of life here we consider it's not recycled, so it goes to energy recovery and landfill. So here the weight is 0.729 grams, and for the MCA calculation we have as before the virgin feedstock and the linear flow index. In this case, the virgin feedstock is all the weight of the package. So and then this makes the MCI to be the result is 0. Okay, so the linear flow index is 1 because we are considering here that it's not recycled and it's all made from virgin feedstock. So it would be like the worst case in the circularity assessment. Okay, so what makes the difference between the two approach case studies? So first, the end of life considerations. So the mass of unrecoverable waste, we see that on the first case we recycled almost 80%, while in the second we didn't recycle anything. So the higher the mass of unrecoverable waste, the less circular is the product, because if this value is really high, or is almost all the weight of the package, is because it's not being recycled, so it goes to landfill. Okay, so in this formula that you see here, we consider the mass that is collected for recycling, the mass as component reuse, the mass that could be used for energy recovery, or the mass that goes to composting. Okay, so this is why if the product is not recyclable or not reused or not used for energy recovery or composting, so it goes to landfill. So this will be this value will be higher. So this is why in the first case, on the first approach, we have better results in this part. And also another difference we found between the two case studies is the virgin feedstock. Okay, we are not trying to compare the two case studies because they are different. The function is different, but we can see differences in the results obtained. So when we talk about the virgin feedstock, the lower this value in comparison to the total weight of the package, the higher the circularity, which makes total sense because in circularity, if we are using a feedstock derived from recycled sources, from reused sources, or for sustained production, it should have a higher circularity result. Okay, so in the first case, in the approach 1, the feedstock of the cardboard is originated from sustained production, whereas on the second case, all the package was coming from virgin feedstock. Okay, so what conclusions can we take from the circularity assessment? Well, the circular economy takes a different approach. So instead of allowing valuable materials to go to waste and natural systems to be degraded, it applies the three principles that we commented before: eliminate waste and pollution, circulate products and materials. Okay. So circular economy business models can, for instance, help companies meet their climate change commitments, get ahead of government regulations to protect biodiversity, and increase the security of the raw material supply. So here I would like to highlight the importance of pre-designed packaging for improving the end type of products, as well as redesign the feedstock origin, because it can lead to an increase in circularity, as we have seen in the two examples. So design is a force for change. So we should design for recycling, as commented by Estela. So design has the power to reshape our economy. So by embedding the three principles of the circular economy throughout the design process, we can make the economy work for people, business, and nature. So this is all from my side. I don't know if you have any further questions.
Thank you, Carla. That was very, very interesting. And it seems pretty complex also to gather all the information needed when doing this type of analysis. As I don't see a question, I would like to ask one question that came up from my side. You introduced like the list of indicators that you considered for preserve. Does this list differ between different projects, or is it like the let's say the indicators that are most representative, or let's say the ones to go forward when doing a circularity assessment?
With regards to the question, Kristina, okay. For measuring the circularity, the most popular indicator is the MCI, the Material Circularity Indicator, that, well, the Ellen MacArthur Foundation guide shows how to calculate it, and it's total public, so it's really transparent. And also, well, in the task of preserve, apart from this explicit indicator, it commented to select a set list of indicators. So we wanted to connect the circularity assessment with the life cycle assessment, so that it's carried by entity. So we try to connect these two tasks because it's really interesting. I mean, we can say that the circularity of the product that is being developed it's better than the benchmark, but then maybe the cost is higher and the climate change is mostly the same as the benchmark. So we're trying to link all the tasks together in order to have the overall view of the sustainability of the demonstrators of preserve.
Okay, thank you. Yeah, thank you very much. And also, there's another question in the chat. The question is where the circularity indices will be applied as a real-world example. So would you say that a product manufacturer could use these indices to present how circular the product is?
Yes, totally. I mean, this guide from the Ellen MacArthur Foundation is totally public and transparent. So a product manufacturer can download this guide and follow the formulas. It's quite easy. And also I think they have like a tool for analyzing. So it's really easy, and it should give you our results. The only problem here is to really to get to know which is the end of the life of the product. So it is because depending on the country you are distributing that product, it can be different. So for preserve for the benchmark, maybe it could be you can take it as an idea. We use the Eurostat statistic on the end of life. So this can be used as a guide for this part. But yes, totally, you can analyze this. A product manufacturer can for free analyze it because it's public and transparent. So it makes really transparent this guide.
Okay, thank you. Thank you very much, Carla, for answering this question. Okay, so now we're at the final part of our workshop, which is the open panel discussion. And as usual, please feel free to ask all the questions that you still have. Carla, please switch on your camera again, and also Robbe. No problem. So everybody in the audience is as I said, feel free to write the questions on the chat or raise your hand and ask them in person. Okay. But I think for a start, I would start with one question. Or is there already a question from the audience?
Yes, maybe from my side, sorry. I have a question regarding the biodegradability. You mentioned that the regulation is very much into the recyclability. How is it tackled by the European Commission, the biodegradability criteria? Because is there any horizon to integrate and separate the biodegradability criteria separated from the recyclability criteria, basically? Because I know that some countries like China are mostly considering that separately as recyclability. So
I guess this question is for me, but whoever also from my colleagues also wants to come up with. Thanks, Thibaut. So yeah, I mentioned in the chat, someone else asked, I think, Victor mentioned something about also compostability. I didn't speak much about degradability in the presentation, indeed, because this is, and as I mentioned in the chat, this is sensitive. Let's say the European Union legislators have a clear preference for reuse, recycle, refill. And this is due to it's a matter of principle. This is the principle kind of pyramid that they want to follow. Not that they oppose, as I think, as principle biodegradability, obviously, but this it's very much has to comply with certain requirements that are very stringent to avoid pollution, right? And that is where they are very concerned about legislating, and they want to be extremely rigorous on what is put out there and regarding the requirements for biodegradable and their end of life, you know, the compostability, etc. So, but still, the PPWR, the packaging and packaging waste regulation, it's has kind of given, or probably will give once we have the final consolidated version. It kind of gives a mandate to the European Commission to work with CEN, with the European standardization body, on a composting standard. There's actually an industrial compostable standard, the EN, let me say, 13432. I think I always miss the numbers. I can write it in the chat, or someone else, if it's in the chat, can write it. So there is a standard on this, and there are there is an intention to work more on this field, but also the packaging and packaging waste regulation has been very strict in restricting what can be home compost, and why there is still a very, in my view, much more work to be done on biodegradable, on legislating on biodegradable. And yeah, someone put it there in the chat. The horizon, what is the horizon? The horizon is that there needs to be much more work on that. That is what I can tell you. Because it's there is a lot of potential, but then there is a lot of caution. And there is no level playing field with with other type of fossil base, for example, and or that are not biodegradable. So this is something that needs to be worked, and that we, for example, at the European Bioplastics, we work towards this and always kind of say, well, we need to work more on biodegradable and legislating on biodegradable and criteria, and not the criteria. And we have lots of organization, experts, projects that are working in biodegradation testing in all the different environments. There is you have TÜV Austria, you have the certifiers, TÜV Austria, DIN. They are they have the certifications for the composting, but there's the standard, but this needs to be then reflected on the policy in the regulations. And that
Okay.
is a mission to be, and the member states to do this.
Yeah, thank you very much for your answer. So you don't expect any major change in the years to come with regards to that specific criteria. I'm thinking about the PHA, for example, development that will be a bit hindered by that, actually, and it will possibly be developed elsewhere, but not in Europe, at least short term. That's
I don't expect any, but I'm perhaps not the person that it's called totally inside of exactly the biodegradability criteria for a PHA. This is a question to put to the European Commission and say, hey, you see that they're moving so much faster in China, for example. I read something, a report a couple of days, and they're moving so much faster. What happens here? What are we doing here? Can we move faster? What does it take to move faster? What do we need? Are we making sure that everything is safe and sustainable? Yeah, this we need to put the question to back to the environment.
Yeah. Okay. Thank you very much.
Yeah, biodegradability is still a difficult topic, and in Europe, as Estela said, it's always about avoiding accidental littering. And I think also changes in the legislation need to be accompanied by, let's say, some education campaign to also for the consumers to understand what is biodegradable, what is compostable, and why I should not discard a biodegradable PLA cup in the forest. We are developing high-performance bio-based packaging materials in Preserve. So what key innovations do you think from our project may have like the most impact on enhancing sustainability and packaging? Anyone?
I think maybe if we look at the Preserve, I'm not sure if there's really one thing that I would say I would take out of this. I think really from the project we have learned so many lessons into really creating these food demonstrators that we want to be fully bio-based and everything that goes with it. And I think we have learned really, if I look, for example, with the PHA, the possibilities that we can do with this PHA, there are a lot of them, but also, and maybe that is even also an important lesson, is some things that we cannot maybe do with the PHA. For example, also with the barrier properties that we needed some metallization. That was maybe not predicted at first. So there are a lot of possibilities. Also, the way protein coating is also good in some levels, and some others maybe not. So generally, I think there's a lot of things we can take out of this. Maybe I would take the PHA one because really, if I look at the barrier properties, there are some very good results. But I think that it's more general than that.
Yeah, I agree. It's also a multiplayer project. So of course it's not one. It shouldn't be one thing. But yeah, we learned a lot. As López said, there were a lot of lessons to be learned as usual, and also navigating the maze and with all these other regulations coming up, and how then Preserve fits into this, and also considering all we're all coming from different countries with different backgrounds regarding how is the recycling infrastructure, what is really recycled, what not, and also kind of like reflecting this in our project, I would say. Are there any other questions from the audience so far? So maybe another point would be to reflect a bit on how we actually was done in the project, was like with the circularity assessment, how is this ideally supposed in, let's say, in a real world scenario to be integrated in packaging development?
So from my view, the circularity assessment can help, especially on the design phase. So it's really important to take this into account when designing a product. I think Estela also mentioned. So redesign is the force of change. So when we are designing a product and we say, okay, circularity is 0, 0.5, and we need to know, we need to try to make it as much circular as possible. So yes, I think that's the main view. For the moment, there are no much methodologies on circularity assessment. We have this MacArthur Foundation guide, and also which is public, but also in May this year, so it was approved and an ISO standard regarding circularity. So it's really new, but I think it's an innovation for manufacturers or packaging producers to start calculating this circularity indicator at the design stage. So this could be a way to incorporate this in real life, for now. I cannot say
integrating it at this design stage is probably together when you're already considering all the different regulations, probably like have a to-do list what to consider. That sounds very, very reasonable. And also when we are talking about preserve and all the things we developed, and at any stage, from regulatory point of view, from sustainability point of view, and then also from a processing point of view, what do you guys think is like the major challenges or the key challenges and really bringing it solutions like developed and preserved to the market and scaling and commercialization?
Maybe I can go. I mentioned already a bit during the presentation that we've made this joint white paper with other projects that work also on bio-based packaging for food and drinks, but not only. And we have actually during these clustering activities, we have come together to think about what are the common challenges that we are facing, and not only these projects, but let's say the sector, right? And obviously, from my presentation, you would not be surprised that one is the regulatory uncertainty, meaning we are working, especially for us, know what we're doing in the project. So and you have to understand how EU projects work too, right? So we are at the end of our project this December, we are finishing after 4 years. We created this proposal some 5 years ago with the status and the state of play of 5 years ago of the sector, right? And some things have moved and some things have moved very, very slowly, like snail, and some things have changed not at all. And but a main challenge that still applies is the regulatory uncertainty, obviously, and per se, I think that's inherent when you do anything innovative packaging, right? you are working on a framework that exists, but already you have to look at the things that are being developed regulatory wise, because you have to comply always with that to the more little detail. And it's not only about the chemicals, it's about the sustainability, the circularity, your claims. It's about the end of life. It's about everything, and you have to take into account all this. That it's already an uncertain per se kind of modus vivendi that we would have. But on top of that, there are other things that are being proposed that we don't even know how this will end up. For example, the packaging and packaging waste regulation that I mentioned. So this regulatory uncertainty is a major challenge. The evolving nature, right, of EU legislations. This uncertainty regarding the final requirements for bio-based, for compostable, for biodegradable. This makes it difficult, long-term compliance, and of course, investment. Then of course it's very tricky to invest on something that you don't know, and this we're speaking then about producers and users, etc. To invest on something that you don't know if you can market, if you can sell, if you're going to get the return. That it's difficult, and this is of course linked to the lack of harmonization, right? The differences in the national regulations. So all this makes it tricky. It's a challenge, but it's also an opportunity to within the project be able to keep working on the direction. And actually, we have seen by my presentation and Kristina's that what we were doing in Preserve, it's very much in line with what's being proposed at the PPWR in terms of the percentages of recycled content, etc. So this is a challenge, but it's also it can become an opportunity because we are moving in that direction.
Yeah, we were actually quite lucky to already align with all these changes, because as you said, we started. I think the first stage proposal was 5 years ago, and the final stage was then 4.5 years ago, and it changed a lot. And the regulatory maze is amazing, so to say. And probably also one challenge could be that the policy is one thing, the infrastructure and investment then on the recycling part is the other thing. It's from the reprocessing part. Robert, what do you would say is one of the key challenges from project to market?
Definitely with the regulation. I mean, with the companies in the project, we already talked about it, but also indeed with the material-wise recycling. I think if we look at it also maybe a little bit bigger than just Preserve, where we really try to recycle the specific demonstrators, we also look in the waste that there are contaminants when you try to recycle them, especially PLA, for example, with PET. It's really a contaminant into them both, and they are not separated at the moment completely. I know there's a project in University of Maastricht. I think that they are looking into the PET one, what's the contaminants of PLA, but also I think differently looking into PLA itself, like how is it recycled. I think we look back then at also the question that we had with the compostability. Do we need to look into recycling or into compostability? That also there we need to be able to separate the PLA, look into compostability, and have the facilities ready to compost this as well. Because right now, this is still ongoing, going into larger and larger volumes. Where are these volumes going to go to? Where are the facilities necessary for this? And again, regulation-wise, is this necessary like Europe for PHA? We want to go to compostability. How is it then specifically into that? So there are many, many challenges going from waste collecting to mostly separating the waste, and then the recyclability. Because for now, I already see challenges when we look at the pure waste streams. When we look at pure PLA waste streams, then it's much different when you look at contaminants also inside this waste stream.
Yeah,
if I may add to this, actually, what Robert said, this is something that we identified in the white paper. This is an issue, a key challenge that we identify, technological, logistical, but also it's the collection, sorting, and management of waste, including recycling streams, right? I mean, the current waste management infrastructure needs improvements, particularly in terms of collection and sorting and recycling, to effectively handle bioplastics. No, it's only a limited number of plastics right now are sorted for recycling, with the highest market shares, PET, PP, PE, and in specific cases, PS. So it's clear that several other types of plastics are entering the facilities, but due to low volumes, will not be recycled. So there are lots of challenges here that need to be sorted out. We recommend to double on investment in infrastructure and to also tackle this by promoting clear standardization and labeling. This needs to be a holistic approach that comes from very different places, and keep on supporting innovation in recycling technologies and infrastructure. It's key, but you also need the incentive to incentivize the political and economic support. And the big elephant in the room as well. Well, there's no level playing field with fossil based, so that is already setting the tone.
Yeah. Regarding the investments for the waste collection and the infrastructure, that I totally agree. What we need to take into account that when we're talking about investments in the infrastructure and the collection, it's not only about, for instance, in Germany, there's like the yellow bag, or whatever you want to call it, where you put all your packaging material, including plastics. However, we should not only talk about this, like how you really sort all this plastic, but also within the bio-based treatment facilities, because, for instance, in Germany, they are often run different municipalities, and not all of them are equipped, for instance, with software to identify when there's plastic coming in, is it biodegradable or not. So when you have all these biodegradable plastic bags, in other countries, I think they are safe to be put in the bio-waste stream, and they can be biodegraded. For instance, in Germany, what often happens, not in all facilities, but depending on the facilities and whether they have or do not have the sorting system, they will not identify whether it's, for instance, PLA or any other degradable plastic. They will just see it's plastic, and they will take out the bag and send it to incineration. So when we're talking about investments, it's really, I just want to emphasize that it's really the whole waste management sector. And I think that's maybe also another challenge coming up when we're talking about expanding the use of biodegradable plastics, that not only means investments in the plastic recyclers and the plastic collection system, but also in the bio-waste collection system. And I think for again, it's also about educating the consumers and make them aware why it is important to really separate the cup and the lid, the tray and the lid, take off this paper, cardboard banderoles, and really disassemble your packaging, as this will also, of course, increase certain waste streams or material streams.
I think it's not that there's, I mean, you're absolutely right. And again, mentioning the paper, we already identify a key challenge as consumer awareness of, well, first of all, of what are these materials, so the difference between the different type of packaging that they can purchase, but then disposal, that is so important. I can see how if kids are always assembling Legos, why they spend hours and hours and parents together, how cannot you disassemble packaging that can be easily campaigns done around that. But what you said about the waste management in investment, there is something that goes beyond investment, that it's about commitment from, and that is very, very tricky, from the different levels of government in a member state to actually work together, because you can pour money at central level, but if it doesn't reach the municipal level where it's actually the level where this is being handled.
Yeah, you're absolutely right. It's about commitment and working together, collaboration. Yeah. Thank you very much to all of you for taking part in this workshop. And maybe as a conclusion, what are your key learnings from today, Estela?
I'm muted, right? Yeah. My key learnings is that actually we are in the right path. We're in the right path, meaning the European Union has it has good objectives. I mean, what can I say? I'm a convinced European citizen. I think that the objectives that we have in sustainability, climate, environment, consumer economy, they are the right ones. But the way that we achieve those can be really worked on because we're seeing that other types of political systems and countries like China, they're really surpassing us. And then this is something that needs to be monitored, and therefore we need to work on that. But projects like ours and clustering with projects like ours are actually working to make this happen. And my key learning is also that we need to be much more involved in these conversations for all this legislation, for all this implementation to actually work. This is a conversation to have together, and our expertise is very valuable, and we need to put it forward and forward and forward.
Yeah. Thank you, Estela. Also, Carla, your key learnings or key message of today.
So I would say that also as Estela, we are in a good path because a lot of efforts have been put in research in make the product more circular. So we hope in the last 2 months that we have to finalize to achieve this objective, but also that more effort has to be put, especially in legislation, and as Estela commented, on implications in to make all of these research that we are doing work in a future.
Yeah, thank you, Estela. Robin, last but not least.
Thank you. So I think my key learning, as also Carla and Estela said, like we are on the good way, but there are on a lot of different levels that there are more questions popping up, more research questions as well, like technical that we need, like bio-based is a very good idea, biodegradability, recycling, but it should not always be bio-based or maybe bio-based or not always compostable, but definitely recyclable, like looking at circularity at a level that it is also feasible that we can do this. And like we also say with the waste management, that on that level, it also needs to be more improved. And yeah, the further we go into this, the more questions actually pop up. But now, like we also need to keep this further, keep other projects going on to keep improving this.
Yeah, I totally agree that it's efforts of all, and yeah, we are on a good way, and a lot of other great projects that are also pushing and coming up with innovations. And yeah, I agree, it should not always be the question about does it really need to be compostable? It's probably also depending on the application. And also to close really the loop for circularity, recycling needs still to be pushed, and the infrastructure to be improved on multinational and then also intranational level. Yeah, I hope for the audience you enjoyed our workshop. Thank you very much for joining us, and yeah, have a great day. Thank you.
Kristina, I want to remind
about thank you. Thank you. Yes, we are finalizing our project. So on the 12th of December, we will have our final event in Berlin. It will be a hybrid event, so please feel free to join us. You can find all the information on our LinkedIn profile, our website. Yeah. And maybe
share the link now in the chat as well.
I was about to say, maybe Estela can also quickly share the link for registration. As I said, it's a hybrid event, so you can feel free to join us in person. We're happy to meet you in person, but also we're happy if you would like to join online.
And one question regarding the presentation, will you share it with us, or?
We will we have recorded the workshop, and we will upload everything to the Preserve website on our social channels. So keep posted. I'll send a little email with the links once they are all up there.
Okay, thank you.
Okay, thanks again for joining our workshop, and have a great afternoon or lunch break and then afternoon.
Thank you, Kristina. Thank you for the moderation.